In this session, we're going to briefly touch on hydrocyclones and dense medium cyclones. If you look on the stand, the hydrocyclones and the dense medium cyclones are very simple devices. They've got an entrance point and two exit points. But unfortunately, when people start to understand how the basic principle operate, they believe they are experts. Why is that? To explain that, I may need to quickly divert to a different topic. In 1995, a guy called MacArthur Wheeler walks into a bank in Pittsburgh and robs the bank. He went on to a second bank. A couple of hours later, he was caught. And he couldn't understand, why was I caught? Because he has wore the juice. That juice was lemon juice. Lemon juice is used as a secret ink. And his belief was that if he was the juice, he became invisible. This topic caught the attention of two university professors, Justin Kruger and David Dunning. They did the investigation, and what they realized is that when people get a little bit of information, their expert levels increase dramatically. Up to a point where then with time, you came to realize, but I don't know that much. You then start to go down in your confidence levels, and then you start pick up again, and then you become a real expert. And that applies to the cyclone as well. Because the cyclone sits in the center of a beneficiation process. That simple operation doesn't mean that if you understand the basic principles, that you will solve your problem. In this flow sheet, you've got a dense medium cyclone that's situated in that territory, and we've got a hydrocyclone. And both of them, when they're not operating correctly, is going to cost you money. But when you have a metallurgist or even a supplier that knows a small amount of information, all of a sudden they become the expert and they become talking all sorts of nonsense with us, or the supplier with the client. So this is just to explain sometimes the impact that these two simple devices in the different territories can have on a process. We've got in the dense medium side, it's just an evaluation which any metallurgist can do. If you understand the different activities in your mining process, and you allocate a value to that, which is not impossible for you as the metallurgist to get that information, you can then go and have a look at the impact that in this example now, a dense medium cyclone have. The efficiency of a dense medium cyclone, and for those who don't know what dense medium cyclones is, that is a device that will separate coal from rock, and it does so in a very short period of time. But that unit, because there's so little time, it has to operate as efficiently as possible. If you don't help that unit to perform correctly, it becomes inefficient very quickly. And this is what the values on this x-axis illustrate. The higher the value, the lower the efficiency. These two lines represents an ore body, which is a good ore body, a high yield type of ore body, and the black line, an ore body that does not yield a lot of coal. The point is that if you start to experience inefficiency, the value or the revenue per year that mine experience can decrease quite significantly. If you've got a low yield ore body, you can go into bankruptcy if you're not careful. And it's not very difficult to get in this territory. And that is where we as suppliers need to be experienced enough so that we can help our clients. On your right-hand side, this is for an ore body that is simple to separate, an easy to separate type of process. You don't see that significant reduction in revenue, but still you see a reduction. And we as suppliers, but you as metallurgists, both of us has got a responsibility to benefit our ore bodies as efficiently as possible. That was on revenue. As the efficiencies start to deteriorate, in coal, we are misplacing coal in the wrong direction. It does not only represent money, it also represents energy. So this black line illustrates the amount of tons of coal that we are throwing away. And this is only on a 300 ton an hour coal processing plant. So we're talking relative small scale, but the impact is significant. The red line is the associated energy. And again, the metallurgist would, if you've gone to this point, will say, okay, we're losing energy. But that's not good enough. Because we have a responsibility to the social environment as well. That energy that we are throwing away is enough to give this amount of people energy. So we are throwing away coal, we're throwing away money, and we are depriving the social environment from energy. That is not how we should operate our business. That was now in coal. Another example on dense medium is on diamonds. This diamond plant sits in Lesotho, and it is renowned for producing some of the largest diamonds in the world. Very good quality and therefore very expensive. These are the diamonds that was produced over some of the diamonds that was noted on the internet. And these were the values that the diamonds were sold for. And you think, well, okay, so what? It's a diamond. This diamond has gone through a dense medium process, and here's the dense medium cyclones. The time the particles spent inside this dense medium cyclone is a couple of seconds. The reality is that if you look at the value of the diamond and you divide it by the number of seconds that the particles spent inside the dense medium cyclone, every second the cyclone had to make a decision, and that's the value of that decision. And that is why for us as suppliers, we must know our business, but it's also for us to transform, to give you guys, our clients, the knowledge to understand the impact that a simple device like this can have. If we don't know our business, we are going to push you in the wrong direction, and that is the impact that it can have. The dense medium cyclone sits in the middle of a process. Here's the overall dense medium process. And these different colored lines are different process streams inside the dense medium plant. And each one of these different color streams does impact on the dense medium cyclone. But these days on the internet, people go on the internet, they get an idea of how the cyclone works, and then they're expert. But guess what? In the internet, they only tell you how that unit operates. They will tell you how the screen operates. They tell you how the pump operates. But very seldom do they give you the complete picture. And that is our business. That's why we've got these training sessions that Brent Combrink was talking about earlier, is to help you see the bigger picture. If you then want to optimize your dense medium cyclone, you start with the cyclone. We inspect the cyclone. This is the easy part for the metallurgist and for ourselves. But then you need to step back. look at how the dense medium cyclone operates. What factors influence that performance? Once you're comfortable with the dense medium cyclone, your job is not done. You have to step further back and have a look at the overall process inside the plant, the feed rates, the size distribution, how auxiliary equipment is operated. And once all this equipment is operating correctly, together with all the optimized items we've already covered, then you have optimized the dense medium process. And that is where we want to be. This was now on dense medium cyclones. On classification cyclones, which is a device that sits in this area, the purpose of the classification cyclone, and around the corner is a typical hydrocyclone, is to separate fine particles from coarse particles. And very seldom do people pay attention to what impact that device can have. What happens when you separate the wrong size fractions in the wrong direction? This example is a plant that's treating 1,000 tons an hour. Only 15% is the fines that's going to go to this hydrocyclone. The yield from this cyclone underflow, which means in this example, the underflow goes to a spiral device. That is an example of this turning spiral that's standing on my right-hand side, on your left-hand side. That's a spiral. You can recover 60% of that material. If you allocate a value of either 825 Rand, if it's an export coal, or an Eskom coal that's only 320 Rand, what would the impact be? You only get a size distribution. The metallurgists get a size distribution, they give it to us. What do we make of this when you have a good size distribution or a poor size distribution? Because the reality is you don't know which one is bad and which one is poor. We have to analyze the overall picture. This is what the size distribution would look like. You look at this and you say, okay, so what? The efficiency of the cyclone, of the good cyclone, would be the blue line, and the red line would be the lower efficiency. And that's where most of the people stop. They say, well, the cyclone is not operating correctly, or the efficiency is relative poor, and they stop there. So go further. And that is what we are trying to help you with. Because if you look at these two examples, your export scenario, which is your high value coal, if it's operating incorrectly or at a lower efficiency, you are losing in the region of 13 million Rand per year. That equates to about 64 cents per second. Again, we think it's small money, but add it together and the price start to increase. If you look at the Eskom coal that one would presume is a low value product, you can still lose money. And in an environment like this today, it's our business and it's your duty to make sure that you maximize the performance of that equipment so that we can minimize these losses. This is on a fine on coal. The last example is on copper, where the cyclones are associated around a milling circuit. The mill would grind the material fine enough before it moves on to the flotation devices, where the flotation cells would recover then the valuable product. Looking at comparative test work between cyclones that we and a competitor was running against, this was the result that came forth. Very similar performances, except for that area there. What does that mean? We look at this result sometimes, okay, that's a curve, a small deviation, and that's it. Unfortunately, that's not the final story. There is more to this. This is the overflow size distribution of an efficient cyclone, and you've got the overflow size distribution of the less efficient cyclone. Again, you look at the data, and we say, okay, one is better than the other, or they're very similar. Think further, and that is what we are trying to help you with. If you look at the green line, which is the flotation recovery per particle size fraction, the best area for recovery on flotation is the size fractions up to maybe around 200 micron. The finer fractions and the very coarse fractions is not being recovered. What does that translate into? Because it's still only graphs. If you look at the value, you're using a plant feed in this example of 122 tons of copper ore going to the process, 6,000 operating hours, there's the plant feed per year. There's the amount of copper that you produce, about 0.72 or 0.75. That small difference equates to quite a significant value, 2,410 rand per hour. That is on 122 tons per hour plant. The bigger thing is 14 million rand per annum that you are losing purely because of a small deviation on the overflow of the hydrocyclone. The hydrocyclone is again forming part of other processes. There is equipment that is influencing the performance of that hydrocyclone. Again, you go into the internet or you go to handbooks, they don't give you the bigger picture. So if you want to look at a hydrocyclone, you start with the hydrocyclone again. Look at what the unit internally looks like. Optimize it. You then start again, moving backwards. What is the flow behavior of this hydrocyclone? But when the hydrocyclone is operating correctly, it does not mean that the unit has been optimized. You have to look again at a bigger picture. In this case, it is now around a milling circuit. When you're in a milling circuit, you have to understand how the mill operates. You need to understand what the effect of the grind and the cut point is. Looking at the sump level control, the auxiliary equipment, how's the flotation equipment performing? Maybe the flotation equipment is the equipment that's not operating correctly. And then looking at how the pumps is operating. And most importantly, mill feed rate and particle size distribution. So this is a quick summary of the hydrocyclones and dense medium cyclones that is perceived to be quite simple. And our job is to take you from this high curve where you have limited experience and a lot of self-confidence and arrogance, bring you down to a level where you realize there's more to be learned, and then build you up to become experts. Thank you very much.